Thank you, sir. All right, so moving back into Chapter 5. Now, we spent last time talking about the mathy way of doing calculation of elasticity. Okay, so we've done that once. We don't have to do it again. Okay, I'm going to show you the shortcut way today. Now, before we get there, I want to, so I showed you how we were calculating this E coefficient, right? And then I told you that that E meant something. Okay, here is the meaning. All right. Now, the examples that I use after I go through the little mathy stuff is to use a little bit more realistic stuff. All right, so when E is greater than 1, or when the percentage change in quantity is more than the percentage change in price, right? When you raise the price, everyone looked at the higher price and said, screw you, I'm going to buy something else. All right, that's when demand is elastic. Okay, the way I like to describe it is that imagine, you go into your underwear drawer and you're picking out a pair of underwear that you're going to wear today. And if you get out the nice, crisp, new pair, it's got the nice, tight, elastic band, and so when you go to snap yourself with it, or, God forbid, someone else does it to you, when you pull the band off and then you let go, if it's nice and new, it's nice and elastic, what does it do? It smacks you way harder than it got pulled out, right? So, therefore, the smack is worse than the pull. All right? But if you go into your underwear drawer and you've already worn all the nice new pair this week and you're kind of not feeling like doing laundry, so you're like, well, here's a pair that's old, but I can still wear it. And you pull it out. It's clean because it's been washed, but it's been washed a lot. But the elastic is kind of like, and so when somebody goes to snug you at school while you're wearing that pair, they go to pull it out, and instead of it going smack back, it kind of goes, la, 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 la. It's kind of inelastic, right? So when they pull on your not-so-new underwear, the smack you get coming back is less than the amount of pulling they had to do. That's an inelastic type of demand, okay? So this is all talking about how our demand is changed by price changes. All right, now, the thing about these things is that they are also driving revenue. So that's what we care about, right? Whether you get snuggied and it hurt at school is relatively unimportant to the economic world. But these things drive how much money businesses collect. So let's take a peek at this and decide how things are working. All right, so let's first look at an analysis of gasoline. Now, think about this. Think about gasoline. Which one do you think it normally is? Do you think it's elastic or inelastic? And now use this analysis, right? When the price goes up, do you buy less gas? Not really. I mean, you try to, right? I mean, this is the example I give is that, well, it used to be when gas prices were like, $2 a gallon, when you needed to go to the store, you hopped in the car and you drove to the store, you bought whatever you needed, you drove back. Once gas got to be $4 a gallon, then we said, wait, yeah, I need to go to the store, maybe I'll wait, and I won't go to the store until I have to do something else with it, right? So you're still not taking less trips necessarily, but now at least you don't drive there and back, right? You say, well, I'll go to the store and I'll buy my groceries, and at the same time, I'll also go to my dentist's appointment, which happens to be on the same side of town, right? Or that's when I'll drop the kids off, and then on the way back, I'll go to the grocery store so that I'm not taking 2 trips, I'm just taking 1. Essentially, yes, you're trying to save and spend less gas, but in the end, I mean, you're pretty much still buying the same amount of gas, right? So the idea here was that when gas was $2 a gallon, you maybe bought 10 gallons per week. When gas shot up to $3 a gallon, you tried to buy less per week, and maybe you succeeded, right? So instead of having to buy on every Saturday, every 7 days, maybe you pushed it to an 8th day. And so instead of buying 10 gallons a week, you bought 9. And then when it shot up to $3.50, Well, let's just go all the way to 4.
You rode your bike.
You tried to ride your bike whenever you could, but in the end, what happened? Yeah, still probably about the same. Let's just say 8.5, just to be simple. All right, so it did go down, right? Anytime the price goes up, you do buy less. I mean, that's all there is to it. All right? So my question to you now is, how does this denote that our demand for gasoline is really inelastic? All right? Because that's what we think it is. We want to believe that, okay? All right, so I told you that it was based off of revenue. So how would you guys calculate the amount of revenue that a gas station earns from your purchases each week? Multiply. Very good. Because if it's $2 a gallon and you bought 10 gallons, how much did they collected $20 on you, right? What happened the next week when they raised the price to $3? How much did they collect from you? 27, because you just multiply. And last but not least, takes a little work, but it's not too bad, 34. So this is what tells you that the elasticity of it went from $2 to $4, stayed inelastic the entire time. The reason why is that when the price went up, so did the revenue. Notice that the quantity still went down, okay? When the price goes up, the quantity always goes down. That's the frickin' law of demand, okay? Don't forget that one. This is the one thing that tends to throw students, is that they forget about revenue and they say, oh, whenever the price goes up and quantity goes down, it must be inelastic. Well, then everything would be inelastic, which is obviously ridiculous, right? It's purely off of what happens to the money, right? So when we raise the price again, what happened to total revenue? Kept going up. Now, at some point, the price of gasoline is going to get so high that demand is not going to stay inelastic, right? So imagine, if you will, that next week the Middle East blows up, okay? I mean, it's pretty close right now, right? I mean, imagine if there was full-scale war in every country in the Middle East. You know, Kuwait, Saudi Arabia, you know, Afghanistan, Iran, Iraq, all of them. They just all started fighting whoever, even if it's just themselves. But the fact remains, what's going to happen to the price of gas if that happens? It's going to fly through the roof. Yeah, let's assume that all of a sudden gas flops to $10 frickin' a gallon.
I'll be late for class and walking.
How many gallons of gas can you afford to buy per week if it's $10 a gallon? Yeah, I mean, some of it's going to be none, right? I mean, so maybe it's going to be 4 for me, and if we average all of us together, let's assume that we're only going to buy a couple of gallons a week. I mean, that's all there is to it. We just can't deal with it, right? I mean, we're going to say, look, there has to be bus service provided to Black Hawk Tech so that I can get here, because I can't drive. I can't afford $10 a gallon plus the tuition you're paying me, plus the frickin' price of books, et cetera, right? Exactly. And so eventually, what happens, right? The price, when it goes up, what happened to total revenue under that case? It finally went down. That's when your demand for gasoline switched from being elastic to inelastic, right? Or sorry, from inelastic to elastic. Strike that and reverse it. So when they move in the same direction, right? So if the price goes up and the revenue goes up, inelastic. If they move in opposite directions, so when you raise the price, if your total revenue drops, that is where you are elastic. You got the price so high that people just couldn't handle it anymore, all right? Or they just said, screw you, I'm not buying it anymore, all right? Now for gas, generally speaking, as long as the price doesn't hit that critical stage, it tends to be inelastic. Because because we have to drive everywhere we go. That's the nature of our country right now. Right? Yeah, I mean, we could go back to horseback, right? Or, more than likely, what will start happening is if that gas gets up to $10 a gallon, the U.S. will become more like Europe, where there's a train from every city to every other city. And if you need to get somewhere, you'll just hop on a train, right? Yeah, you'll have to pay a few bucks, but whew, train gets you there, right? Mass transit. But gas prices have not gotten that high, at least for this country. In Europe, $3 a gallon was enough for them. That's just them, though, okay? So part of this is why I'm trying to point it out, right? This is the economic situation that's going on. And because these gas stations are constantly seeing that as they raise the price, their total revenue doesn't drop, what's going to keep happening to the price? Right? Very, very rarely do prices ever go down, all right? Generally, what companies are trying to do is they're raising the price and looking at their total revenue. If they raise the price and their total revenue goes down, that's when they stop raising price. That's when they stop it. Right? That's the only thing that stops it, is money, because this is this section of class where that's all we care about, okay? All right, now, so that's gas. Let's look at, say, something else that's maybe not quite as inelastic in general. So let's think about corn. So corn on the cob, so sweet corn. All right, so what does an ear of corn cost nowadays? A quarter? 25 cents? 50 cents maybe? Okay, so let's start at 25 cents. How much corn are we going to buy at 25 cents an ear? Okay, so let's say per week maybe we buy 8 ears of corn. Okay, reasonable. I do like corn, so yeah, you will discover quickly that I like corn. Examples will, yeah, enough said. Anyways, let's assume that an ear of corn shoots up to, well, screw it, let's just go to 50 cents an ear. 4? Well, for me, 50 cents, I still kind of like corn. Maybe I'm going to keep buying 6, right? I like corn. Now, it may be different for you, right? And that's okay. Remember that your demand can be different than mine. But now let's suppose that it keeps going up. Let's suppose it goes up to 75 cents an ear. I mean, I like corn, but I'm perfectly okay with green beans. Right? I don't even mind lima beans. I don't really like peas, though. I like carrots, though. I would buy more carrots, right? So my guess is at some stage I'm going to say, I'm going to go, I'll still buy a little bit because it's corn. How can you not buy corn, right? I mean, and let's suppose one last time it goes up to $1.
I'm not buying it anymore.
Yeah, I'm not buying it for $1. No.
Oh, I mean, what if it's really, really good, right? I mean, it's really good. You know, you've been by this store at the roadside, and you know. I'll still buy one. Okay, so my question to you is, where is my demand? Where is my price elasticity elastic? Where is it inelastic? And potentially, where is it unitary? Multiply, okay? Please don't just immediately say, well, the price went up, the quantity went down, oh, therefore it's elastic, right? No, don't think that, right? So you will always say, perfect, get out total revenue. You guys like to multiply, so multiply. 8 quarters, $2. 6 50-cent pieces, $3. $1.50 and $1. Okay, now we do our analysis once you have the total revenue curve, right? And this time, I'm going to go, instead of going from the top down, I'm going to go from the bottom up. Why does it matter? It doesn't, okay? But when I go from $1 to 75 cents, what happened to the price? $1 to 75 cents? I'm going from the bottom up. Don't look at the total revenue, right?
Okay, so revenue
Yeah, looking at the price first.
down.
My price went down from $1 to 75 cents. What happened to my total revenue? It went up. As long as these two things are different, as long as they're different, we're elastic. And again, think about it, right? If one of them's positive, one of them's negative, they have to be stretching apart, right? Hence the elasticity. When it's inelastic, if they're both moving together, when you go to pull one, the other one gets pulled along with it because they're inelastic, right? There's no stretch to it. That's another way of looking at it, right? So here, what happened to our price this time? Still went down. What happened to our total revenue? Still went up. We are still elastic at this stage. And then one last time, our price went down. What happened to our total revenue? It went down. Now they're the same. Switch to inelastic. And of course, what would happen if it was unitary? It would be these two things staying the same, right? So if I would have said 4 here instead of 6, and these were both $2, that's unitary. All right? All right, and again, this is what businesses are doing. This is why this is important in this class, is that businesses care about this column, right? And so what they're constantly doing is saying, raise the price just a little, and then they do an analysis of their total revenue. And if their total revenue is still going up, folks, they will always keep raising the price, period, right? It's only when revenue drops that they say, whoops, maybe we raised the price too much, maybe we need to start scaling it back. All right, and again, you guys know that probably doesn't happen that often, which is true. All right, so this is, Amanda's going to hate me for doing this, but I'm going to do it anyways. So elastic, tacked onto this, another definition of elastic, price and total revenue move in the same opposite direction. So when price goes up, if total revenue goes down, you're elastic. If price goes down and total revenue goes up, you're elastic. So price and total revenue move in the same direction. So if they're both positive or they're both negative. And the cool part about it is that it doesn't matter which way you look at it, right? The reason I was going up on this line was so that you could see price going down. If I went the other direction, if I let price go from 25 cents to 50 cents, what happened to the price? It went up. But when I'm going from here to here, what happened to total revenue? It went up. So you can either see this as 2 pluses or 2 minuses, and that always works that way, okay? That's the nice part about the math on this side of it. You don't have to worry about it. So either way you like to go. If you like to go down. If you like to go up, go up. Whichever way, you're still going to get the same answer, all right? And then last but not least, unitary. When total revenue does not change. All right, so this spot, this tends to be the spot that businesses are trying to look for when it comes to their price. They're really trying to find the price that is unitary. Now, let's do a quick little check and think about why. So 1, 2, 3, 4. And let's just assume that, make it simple, right? So this is 4, 3, 2, 1, whatever. It's nice, easy. One of them are the prices, one of them is the quantity. So you guys now know, when you see this table, what's the first thing you guys are going to do? Multiply. You're going to make another column, and you're going to talk about total revenue, because that's what we care about, money. So you're going to multiply your numbers. You're going to say 4, 6, 6, 4. All right, so now you are business owners. You're looking at how much money you're collecting from your individual customers, and you say, I can maximize my total revenue at either $6 or $6. Okay, so where are you going to set your price? 2 or 3? Why 3 and not 2? The revenue's the same. Why is quantity lower better? Because it costs less. Okay, please remember that you're a business owner. When you're going to sell stuff, you have to at least get the stuff first, right? And you don't get it for free. Would be nice, but it's never free, right? Never. You always got to do at least a little work to get some. All right? So in this case, even though your total revenue is going to be the same at either price, you're going to set it at the higher price because then you will spend less in order to get that $6. So if each one of these things cost, say, 50 cents to make, right? Realize you would have to spend $1.50 here, you'd only have to spend $1 here. Your total profit is higher under that circumstance, all right? It's just sort of a general rule of thumb for how price changes work. All right. Let's see, let's make sure I don't forget anything. Oh. So, you guys are probably going, okay, Marshall, this is all well and good. You're talking about demand. This is really all about demand, folks. So if I'm talking about demand, how come I haven't drawn any demand models up here? Well, because I haven't gotten to it yet. So we need to model this. Because what we're trying to do is to get a little bit better understanding of demand, because that's what this is all talking about. Okay, so let's think about that gas example, where when the price goes up, we'll buy less, but not a whole lot less. All right? So imagine, if you will, that here's $1 a gallon, here's $2 a gallon, here's $3 a gallon, and here's $4 a gallon. Now, I put $1 in here because when I first started driving a car, folks, price was 98 cents a gallon.
It was only like $1.10 when I started driving.
Wasn't that nice? Yeah. Sigh. Anyways, sorry, getting nostalgic. So at $1, well, at $2, how much gas was I buying? Roughly 10 gallons, right? And when I hopped up to 3 gallons, what happened? I only went down to 9. Whereas when I got up to 4 gallons, I even went less. I only went to 8.5. What do you notice about that graph? It's pretty steep, right? That's where your demand is a little bit more inelastic, right? If, on the other hand, we looked at a graph of something that's more on the elastic side, the idea here is that as we move up in price, we're going to see a bigger change in quantity. So I forget what our example was. It was corn, right? So our quantity out here was what? This was 8 and 6 and 2 and 1. It's not to scale, but relatively close. Again, though, note that this curve starts to flatten out. And please realize that elastic and inelastic are opposites of each other. So I could say that it's more inelastic, or I could say that it is what's the same as more inelastic? Yeah. Both of those two things mean the same, right? Because if you're less elastic, default more inelastic. And likewise, if you are more elastic, this is why I like to tell people that negative signs in economics actually are important, because that's really what we're talking about, right? Opposites of things. It's like 2 and -2. Math examples. They always make it easier. Okay, so can you think of a good, or a product, if you will, where the demand actually goes straight up and down? So gas, I mean, it's really steep, but it's not straight up and down, because at some point in time we're going to get to a price where we're not going to pay it, right? Electricity. So imagine right now that it's a penny a kilowatt hour, right? And your electricity bill is like $30 to $200 a month or whatever it is. If they doubled that price, again, you're going to have to need the electricity, right? But eventually, though, right, I mean, if it cost you $5 a kilowatt hour, I mean, you're still going to cut your electricity usage, right? So can you think of anything where when the price goes up, you won't cut its usage at all? Water. I mean, but again, it's one of those that's pretty close up there. It's a nice, really, really, really steep one. I mean, if you don't drink enough water, you're going to be dead. But sewer again. I mean, but you could always do like the dog. I'm talking again. Think about this in terms of life and death, right? That's why water is a good one, right? Because it's sort of life and death. What else? What else might happen to you where if you don't do something, you die? Air, food, I mean, those sorts of things. Those are generic things. Those are also very steep. But think about it if you have a life-threatening disease. Suppose you have high blood pressure. Medications, right? I mean, if you don't take this medication, you die. And what happens to them? They die. So the idea here is that there are some things where the elasticity is almost perfectly inelastic. Where you're going to pay the price or you're going to die. Those sorts of things have demand that is almost perfectly inelastic, right? And as the steepness of your demand curve gets flatter and flatter and flatter, you keep losing some of your inelasticity, right? So here, this is more elastic because it keeps getting flatter and flatter and flatter. So if straight up and down is perfectly inelastic, what's perfectly flat? That's the other side of the coin. That's demand that is perfectly elastic. Can you think of any product that has perfect elasticity, where the price is set, and no matter where you buy it or who you buy it from, it will always be the same price? And on top of it being the same price, you can sell or buy as much of it as you want at that price. How many of you are farmers? None of you own a farm? Okay, that makes sense. Because farmers get this one almost right away. Because what happens when you're growing corn and you go to sell your corn? How do you sell it? Do you go out, do you go down to the grocery store and say, here's my feed corn that you're going to use to feed cows, right? And say, how much of it are you going to buy? No, that's not how it works, right? How does it work, right? If you grow soybeans or wheat or stuff like that, how do you sell it? Well, what you do is you harvest, you put it all in a big bunch of trucks, as much of it as you want to sell, and you drive all those trucks to the silo guy, right? Yeah, to the feed plant or whoever it is that buys it, and they tell you it's going to be $4.38 a bushel. And does it matter how much of it you sell? No, you're going to get $4.38 a bushel. If you ask for more than $4.38 a bushel, how much are you going to sell? None, right? And if you've got 3,000 bushels, are they going to pay you more or less for the last bushel of that 3,000? No, they're always going to pay you for each bushel $4.38. Who decided it was going to be $4.38 that day? That's right, 4 a.m. You can get up and hear him, right? It's the same guy that does the report every morning. You guys listen to this, right? When you get up at 4 in the morning? Is there one? Wow, okay. I listen to it in Iowa most of the time, so it's always an old white guy who must be 3,000 years old. Yeah, because corn prices up 2.5 cents. That's right, because wheat down 2.25 pennies. Beef up a whopping 12.5 cents this morning. All you cows out there better beware. Wheat off a penny. Futures of soybeans are down for December, but they're up for January. Man, you guys have heard him, right? You should get up at 4 in the morning and listen to this guy. He is exciting. I know this because my wife's dad is a farmer in Iowa, and every morning he gets up and at 5 o'clock in the morning for him, he gets upstairs and he pulls out the Philco radio. You guys know what a Philco is? It's the old radio that all it has is AM, and all it has are knobs. It's got 3 knobs. It's got volume, it's got on and off, and that's it. And it's big. It weighs about 30 to 40 pounds because this thing is old. And clicks it on and it goes. And then you get the old guy who gets on and starts talking to you about corn futures. And at 5 in the morning in the middle of Iowa. But my father-in-law, he's staring at the radio like it's going to do something. I don't know, but so I have to look too. So I'm looking at it, going, "What's it going to do? Is it going to explode? Should I duck?" But that's because this at that day he's setting what the price is going to be for everybody that day throughout the world, right? Because the demand is set every day. That's what the price is going to be, and if you sell, however much you sell, that's the price you're getting. Nice, perfectly elastic demand. That's the way most commodities work, right? Where the price is set once and then set for that day, and then rinse and repeat tomorrow, right? As futures get sold and bought in the stock markets that day, the next morning the guy will wake up and he'll get the ticker tape thing and read it to you like there's no tomorrow. It's exciting. Of course, the only reason that I think I don't slip into a coma is that the nice thing about Iowa farmers, they also make the coffee. You basically eat it with a spoon because it's thick. So you take one sip and you're like, whoa, okay, I'm awake. This guy is exciting, right? I mean, okay. Anyways, please realize that when you are graphing demand, the steeper you make demand, the more inelastic your demand is. The flatter you make it, the more elastic it is. So, we know a little about graphing. Modeling. Now, so, the last thing that we have to talk about then in Chapter 5 is what makes our demand in a particular market either more elastic or more inelastic. So what affects the elasticity of our demand. All right, so there is one major component that drives this. This is the biggest one. There's other ones that follow, but this first one is the really big one. All right? Normally, when the price of a good goes up, you're going to buy less. But when you buy less of that good, what are you going to do instead? You're going to buy something else. And that something else, economically, would be a substitute. And the reason why gasoline is such a very inelastic demanded product, how many substitutes are there for it? Not much, right? There isn't a whole lot of other substances that you can pour into your gas tank that will make your vehicle run. Yeah, true. You could pour alcohol in there. It'd run for about 5 or 6 miles, and then it would explode, and it's usually a bad thing. But it's potentially doable. So the number one thing are substitutes. Substitutes. The more substitutes there are, the more elastic your demand is, the flatter you will draw your curve. And the opposite is then also true. The less substitutes you are, the less elastic you will be, and the more inelastic you will be, and thus you will draw your demand steeper. So that's the number one thing that drives the elasticity of our products. And again, that's why when you think corn, its elasticity is it's relatively elastic instead of inelastic, because if you don't want to buy sweet corn, you can buy beans, you can buy any other vegetable out there that works. Even if you really like corn, at some stage you're going to buy less of it. All right? All right, so what else is going to drive our elasticity? Give them to you in the proper order. Time will also adjust your elasticity. Essentially, the more time you have to adjust, the more elastic your demand is. In other words, when the price of gas jumped from $2 to $4 a gallon, the next day after it jumped from $2 to $4 a gallon, if our gas tank was empty, what did we do? We filled the damn thing up, right? I mean, there was no way to avoid it because we have to. But as soon as that $4 existed, what did we start doing? We started saying, okay, I need to start looking for ways to save gas. I need to start becoming more elastic and less inelastic. So this is where you start ride sharing. This is where you start asking, can you carpool? But does that can you find a carpool the next day? No. But you start looking, right? And if the gas prices stay at $4 a gallon for a week, well, now maybe there's 1 or 2 other people that agree. If it stays there a month, now you're finding 3 or 4. If it stays that way for a year, what? You found one, right? And now you start sharing, all right? And so your demand becomes more and more elastic as the price stays higher. And this is why gas companies, they're smart. They're not stupid, right? That's why gas prices fluctuate, because they don't want you to get used to the high price, because then you start changing your buying patterns. So every now and then, price will flatten out a little while. It'll be shorter and shorter, but it's going to go back up again eventually. And again, we'll be stuck saying, oh, gosh, we should really try and find some way to ride share. And yeah, let's do this. And you'll find 2 or 3 people to do it. And then what'll happen to gas? It'll go back down again. And it'll be like, oh, yeah, no, we don't need to. Gas $3 a gallon again. Yay! Gas companies aren't stupid. They know how this works, right? They hire me for $500,000 a year so that I can tell them this is how you do it, right? I mean, and I'm an idiot compared to the people who they've hired, right? So, I mean, they know what's going on. Necessity is also a driver of elasticity. Drug companies know this one. I'm trying to give you all of these as an example of more elastic. So in this case, the less you need it, the more elastic it is. And then obviously, the more you need it, or inelastic it is, right? So the guys who are developing cancer drugs, who are developing AIDS drugs, those people know that you need it, right? So when it comes time to price, they set it at a fairly high rate, and they were only going to see the price go up, right? Because you gotta have it, right? Again, that tends to be what the water company would do to you as well if it wasn't regulated by the government. And the last thing that changes our characteristics, this one, I like to do this one just because I like to say the phrase, right? The breadth of definition. Isn't that breadth? That's a great word. First of all, because it's got bread in it, but it's got a th at the end, so it makes me think of like fractions and decimals. Oh, that's great stuff. All right, so breadth of definition. The idea here is the narrower you define something, the more elastic it becomes. Now, you're thinking, what the hell? How do you make things narrow or broader? So breadth is the noun form of the adjective broad. Think about this in terms of like food. How much do you need, or how elastic would your demand be for, Kobe beef, right? The really expensive stuff that they massage every day and they feed beer every night, and they just get to walk through every, the $38 to $40 a pound beef, right? Yeah, the spoiled cows, right? The cows that get treated better than us. How elastic is your demand for that? I mean, in other words, if the price changed from $38 down to, say, $35 a pound, would you go out and buy a whole bunch of it? Yeah, exactly. You'd be like, this is extremely elastic because I don't need it. If you changed it from being Kobe beef to something that was just beef in general. Now, is your demand going to become a little bit more inelastic? Do you like beef? But beef by itself is only going to be like $5 a pound, right? But generically beef. But if the price of beef goes up, what are you going to do? Buy less. You'll substitute chicken. You will buy fish. You will buy eggs, whatever. If we keep broadening it, though, and say just meat, right? Now your demand for meat becomes a little bit more inelastic because you're like, I need to have some meat in my diet, if you are the kind of person who thinks you need meat, right? So therefore, if the generic price of all meat is going up, yeah, you're going to buy less and less of it, but your demand for it is more and more inelastic as you get broadly defined. And if you take it another step and say food in general, you kind of need to eat, right? So if it's just food, if it's really broad, demand becomes more and more inelastic. You have to have it, you'll pay it if the price goes up. All right? So again, keep these things straight. What makes demand more or less elastic or inelastic? And that, folks, is the end of Chapter 5. Homework for Chapter 5. I have page 109. Has anybody got their book open still? Take a peek. Looks right? Okay, good. And let's do numbers 4, 6, and 8. One of those is going to ask you to calculate E, doing it the fraction way. I would like you to do that for that one problem. I think it's number 4, right? Yeah. So number 4 is going to ask you to calculate E the long way. Please do it for that problem. And if you do it for that problem, I will never ask you to do it on a quiz or a test ever again. All right? So just once. And again, make sure that you analyze it correctly, right? So if you calculate E and it's more than 1, tell me it's elastic. If you calculate E and it's less than 1, you tell me that it's inelastic, etc., etc. And again, also verify that with the revenue method as well. Joe, did you turn me off? Thanks. Thank you, sir.